versus CISC architecture. We also talked about, just one second. Okay, I hope the PowerPoint slides are visible. Okay, so we talked about the fundamental difference between RISC and CISC architecture. In RISC architecture, we said that there has to be very simple few instructions. So it is like a Lego block or like bricks. That they are just brick is of just one type, but if you collect several of them, you can build a huge building, or you can build a bridge, or you can build anything you like. Whereas CISC has got more complicated instructions, and the complicated instructions requires to be decoded in the hardware, so that makes processor quite complicated. Now, just to refresh your memory, I said that CISC was the first instruction set which started. And at that time, it was not called CISC, it was just called instruction set because there was nothing to compare it with. So in CISC instruction set, the reason to make instructions complicated was that at that time, memory was very expensive. So fewer the instructions in your program, the better it is, right? It would save space. It would take less memory. So you would have complicated instructions. And I'm just giving you an example. It is not necessarily the correct example, but suppose if you have an instruction like matmul, that means matrix multiplication, and you give data along with it. Now it is a simple thing, just one instruction. You have asked a lot of work to be done, and someone has to do it because you yourself has not shown it. So in Intel architecture, that work was being done inside the hardware. Then in 1980s, Berkeley, University of California at Berkeley, came up with this idea of reduced instruction set architecture. And that was the right time for this new thinking to come in, because memory had become cheap. Right, so there was not that much of a problem of saving memory, or you have to worry about every word that you are using. So they said that let's make life simple. Let's use very simple instructions, and using simple instructions, you can construct any complicated program. So instead of having, say, a single instruction like matmul, your RISC architecture would have instructions like add and sub, and with the repeated and multiply. And with repeated use of add, sub, and multiply, you can write a program which would do the work of matrix multiplication. Second thing, or ideal thing, which RISC produced at that time was that each instruction was only one cycle long, as opposed to CISC architecture, where each instruction could be of different length. So some instruction may take 15 cycles, some instruction may take 10 cycles. So RISC decided that every instruction should be of one cycle, and this was very helpful in servicing interrupts, because you have to service interrupts. Some interrupts are very important, like if you're downloading something, or let's say you are getting a VIP interrupt from, say, a fire alarm. You have designed a home security system, and if fire alarm sends you a signal, you have to immediately attend to it, rather than, say, asking it to wait for 40 cycles and I will attend to you after that. So processor shouldn't be saying that. So interrupts are taken at the rising edge of the clock cycle. I'm sure you are aware of the function of a clock and flip-flop from your DLD studies. So each interrupt can be taken at the rising edge of the clock cycle. And by that time, a previous instruction would have finished and next instruction would not have yet started. So you are not losing anyone. Whereas in matmul, whereas in CISC, it's an instruction which is set 30 cycles long. If you start servicing the interrupt, say, in the 15th cycle of that instruction, either you would lose all the work you have done, or you keep interrupt waiting. And in some cases, it is not advisable. You may lose data, or you may lose some important information. So we talked about RISC versus CISC. Now, I'm skipping some slides and I will come back to them later. We already talked about this. Now, I mean, here is what I have written about ARM architectural history. Now, I said that, there is a difference between architecture and hardware implementation. As I told you, that architecture is nothing but a set of conditions. So that means it is like a spec sheet, specification sheet, that, it should have this many instructions, it should have this type of interrupt, and it should have so many registers. So, I mean, this is sort of like, architecture. Now, to implement it, you can have various implementation. You can implement it using 3-stage pipeline, 5-stage pipeline. You can use different type of multiplier. You can make your own multiplier, which is multiplying, say, faster or in parallel. So those things are different. Now, as saying that, evolution of this architecture is very, very, in fact, I've been studying this also from the company's point of view and also from an academic point of view. So the growth in the architecture of ARM is directly connected with the growth in the mobile industry. So version 4T was somewhere around like in the 90s. At that time, the phone was just a phone, like your Nokia 3110 or something that, you just dial the number and talk, or you can send an SMS, and that's about it. Then started coming that you should like to have a songs in your mobile phone. You should be able to store songs in the mobile phone. So you started having a DSP, that is digital signal processor type of instructions. Now, these instructions, again, I'm telling you that everything can be done using this 56 instructions which were here. But, companies would say, like TI would say, oh, we are expert in making DSP, and we know that, your now memory is getting cheaper, but still, our programmers would love to write a program, which is shorter, so that, less lines of code you write, less mistakes you make. So they started saying that, okay, we want to have an instruction like count leading 0. Now there is no reason that why you can't do this using the arithmetic and logic instructions, which was there in version 4T. But they said that, why unnecessarily bloat the program? We want this instruction, give this instruction. Now, saturated math, this is good for your understanding. It is very much used in graphics. Say in graphics, say you are using, say 128 levels of grayness. So 0 means completely black and 127 means completely white. And if you want to have any color in between, so color between white and black would be various shades of gray. So if you want to have something which is more gray, then you will say, okay, this is level number 10, level number 50, level number 75, 100. And when you reach level number 128, it will be totally white. If you start coming down, it becomes darker and darker and totally black at number 0. Now, suppose you have written a program in which you want to have your image getting progressively whiter. So you have written a loop that add 1 after every cycle. Now if adder works like a simple adder, so it would keep on adding, it would start from 0 and it would add 1 to it, so it will become 1, then 2, then 3 in decimal. Now when it comes down to 127, so that is like 1 1 1 1 1 1 1, all 8 ones. Now at that particular point, the value is 127. Now program does not know where to stop, so it would say, okay, the loop is like add 1 all the time. So if I add 1 to it, what would the answer be? It will be all 0 0 0 0 0, and the carry would be 1, because if you add 127 plus 1, it becomes 128. 128 is on the 9th position, you have 1, and 8 are zeros in binary. So suddenly your counter, because the carry there's a separate bit for carry, or it is known as overflow. So suddenly your registers from all ones have become all zeros. So suddenly from total white, it becomes total black. Right? So I mean, this is not acceptable. Similarly, if you start saying that, I want to make my image progressively darker. Someone has a question? Okay.
Sir, sorry to interrupt, but I didn't understand how it suddenly becomes white.
Okay.
Can you please explain it again?
Sure. 1 second. Okay. So let's say this is your 8-bit counter. So its bottommost value is all zeros. Right? I mean, this by definition, you have assigned some value to color black. Right? And this is color white. So it is like, logic 0 and logic 1, you have to define some values. So here you are defining all zeros as black and all ones so this is 127 and this is 0. Sorry, I think I have this. Let us keep this for carry. So this is a carry bit. And this is the value which it would read. So this is 127 and this is 0. Okay, so now you have written a program. You want to progressively go from all black to all white. You want to change your pixel from black to white. I mean, you can go directly or, you can go in stages, whatever you want to do. Now, say a program, you have written a program in which you want to progressively make this thing dark, brighter. So it is all black, you just keep on adding one and you're making brighter. At this point, in 1, 1, 1, 1, 1, 1, 1, if you add one more to it, it will become 0, 0, 0, 0. And 1 will be carry. But I mean, this is the thing which is seen. So now from all ones, it has turned into all zeros. Right? So similarly here also, if you start subtracting, if you make it from all white to all black, you start subtracting 1. Then you come down to here. And then, you try to subtract this -1 into from this, then, it would become complement of it. So then, it will all change into 1, 1, 1, 1, 1, 1. You just need to refresh your binary arithmetic, which you learned in DLD. So do you understand it now?
Yes, sir. Get it.
Okay. Okay. So now what they did was in digital signal processing, I mean, if you are trying to design a game in which, you are changing colors, they designed something which is known as saturation mathematics, which says it defines ceiling and floor. That means it would say that 127 plus whatever number will remain at 127. It will not go beyond 127. And 0 minus whatever number will still remain 0. It will not go below this because otherwise you will have this problem. So you have, this is known as 127 is known as ceiling. You can't go beyond number 127. If you keep on adding, your program keeps on adding 1 to it, it would just say, okay, my maximum value is 127. So 127 plus 1 is also 127, 127 plus 100 is also 127, and so on and so forth. So it is very useful in graphics. And same thing from 0. 0 minus anything would still be 0. It will not be a negative number and then, put in 1's complement and get, 111 something into it, which would totally change its meaning. Okay, so that was saturation mathematics. And that saturation mathematics was added, which was an important part. So in version 5, a lot of media instructions were added. Probably you are too young to remember, but probably that was the time when your parents might be, showing off their phone, which is playing songs. You can go to a store and, people used to do that, go and load up 200 songs, and then, mobile shop owners would charge them some money. So, you would. So that was the reason for doing Mac. This extension Jazelle, again, this is a calculated gamble which was taken in what I would say is a business gamble. At that time, Java was becoming popular. I mean, Java is still popular, but that was the rising time. And at that time, just like there is a big hype around Python, there was a hype around Java that, you can conquer the world using Java. But, Java itself was very heavy. And you should not forget the roots of ARM. The roots of ARM was always embedded processor. So, little bit of memory, little bit of space. Processors are also slower. So they say that, it is not easy to use Java on an embedded processor. Why? Because Java requires Java virtual machine. So basically, it's an interpreted language, right? So you require Java virtual machine to run Java language. So they decided to put Java virtual machine in hardware, and they call it Jazelle extension. Now, it sold very well for a little while, for 2 to 3 years. But then changes were made in Java technology. And at that time, just-in-time compiler came. Now, just-in-time compiler obviated the need for Jazelle extension, or Java virtual machine, was obviated by just-in-time compiler. So because of that, suddenly this extension was useless. Now, again, this goes into another tailspin. So now, if something you don't require hardware, it is there in your chip. I mean, all of us would say that, get rid of that hardware. If you are not giving them functionality or no one is using that functionality for decoding Java or interpreting Java, then what's the need of having it? Throw it away and save some money, because hardware on a chip costs money. But it is not allowed. And then you would ask why it is not allowed. If no one is using it for Java, then why use it or why give it? But it's like this. And I always give this example because this was example which was given by the chief architect at the ARM. What he said was that suppose 4 roommates or a family is staying in one house. And imagine you have got old landline style phone in the house. Let's assume that everyone doesn't have a phone, mobile phone. So, and that might be a 20-year ago thing. maybe around the time you were born, that, at that time landlines were the thing to have. So next to the landline, there always people used to keep a diary. So the diary or a pad or a notepad which was kept there was for writing down messages. If someone calls for someone and that family member is not in the house, then you write down the message and that person would come and take a look at that message and then, do accordingly. So it's a very, very primitive type of missed call with message. Now, of course, to write into this, you require a pen. Now you must have known even now that, there's notepad which is kept near the landline. Even now there are landlines in some houses. There is always a notepad and a pen. But, that pen is usually taken away by people. I can't find my pen. And they know that the pen would be lying on that table where the phone is kept. So you just pick up that phone, put it in the pocket, and just go away for that work. So the next person who wants to write message will not be able to write message in it because there is no pen. So these guys decided to come up with a new idea. And the idea was that they would make a pen which is very big, like this big, a foot long, with feathers in the end. Now the logic was that if you have such big pen with the feathers in the end, it would not fit into your pocket and also will not look good. So people would not lift it or steal it and go away. They would just be lying there because no one wants to be seen with a phone like that or with a pen like that. So for a while they kept it. Then they moved on to a new technology. They said we'll keep a pen which is like a normal pen, but we will a small chain. You must have seen the thing like that, and then tied to a diary. In the banks, you must have seen by now that there's a pen and then it is tied with a chain or a string to the table so that no one would like flick it and go home. So when that thing came, then these guys said, okay, there's no need for making a pen which are like this big and with the arm scratcher or with the feathers in the end. And suddenly the customer started complaining. The people who are making this pen were totally zapped. What's the problem? In fact, we have made things easier for them. Because, if a long pen, if you're writing a message, it may like hit you in the eye while writing. So this is a small pen, like a regular pen. All it is like, a small chain which is attached to the diary so that no one would lift it and take it away. Then people started saying that, this big pen, which you have given to me, I use it for like, turning the fan switch on or the ECB. If it falls down, I used to use that pen because it was this big and it was a perfect size. Now you have taken it away and now there's a small pen which I can't even take it out. So I want my old pen back. Someone said that, this big pen was great for scratching my back. Like, I will just put it down that, and scratch my back, the hard to reach places, as they say. And the third person, also come with some similar thing that, I like the feather and then, I can tickle myself while thinking or whatever. So the moral of the story is that once a product leaves the manufacturer's site, manufacturer can't dictate how that product will be used, right? Someone may use an umbrella as a walking stick, right? A larger umbrella. It was not meant to be used as a walking stick, but the manufacturer can't complain that why are you using as a walking stick? Someone wants to use it as a walking stick. So very similarly, the Jazelle extension which was given in the processor, even though the Java language was no longer needed to be interpreted in the hardware, still people say we have found out very ingenious uses for it for writing different kinds of programs. And there were it was not even thought of by the ARM people that someone may use it in a very ingenious way in the program. So they said that, okay, so now Jazelle extension is still lying around somewhere because for the legacy purpose they cannot get rid of it. Because if you are a seller, you have to produce something, which would cater to the consumer's demand, and you cannot kind of piss off your old manufacturers or old customers. So Jazelle is there. Then came mid 2005 to 2010, and that time, you started having smartphone. At that time, your BlackBerry was the big thing. That if you have BlackBerry, you can use BlackBerry Messenger. Some of you may have seen it. So then, at that time, multi-core processor were there. So, multi-processing instructions were added, unaligned data support, and then, various trust zone technology was put in. So, which was for safe banking transaction that, certain part of your data is shielded from the outside world, and so on and so forth. So what I'm trying to say is that progression in ARM architecture from starting from ARM version 4T, T stands for thumb instruction. I will come to that, what thumb instructions are. The progression was due to two things. First one, of course, was customer demand. That, okay, we want this kind of instruction because, now there are a lot of media instruction and we don't want to write a big program for, this very commonly used task. Just give us one single instruction. So those things were done. And now you will see the bloat in number of instructions. So from 56 instructions, now there are 600 plus instructions. So this is interesting thing to know. And, of course, it is okay. Now, this might be a good time to talk to you about, let's take a break and talk about 2 or 3 things which is important to you. That is your lab and your exam. Now in your lab, I have just sent you a mail maybe half an hour ago or so. And that is regarding, I have given you a link, and in link, there is a video. Now this video was prepared by a previous year's student, and it teaches you how to download your Kyle tool from the net and how to write a small program. So it is very instructive. You use it, and you download the Kyle compiler on your Windows computer. It does not work on Mac. So if you have Mac, then I'm sorry, there is no other alternative. You have to somehow figure out a way to access a Windows computer, at least to use this program. I have also given you a reading assignment. I want you to read from chapter 2 to 4. That is chapter 2, chapter 3, chapter 4, and possibly chapter 5. Now, don't worry that, it's a huge task and, there are so many pages, because all it talks about is a very simple thing. And, it is, they have given lots of examples and other things. So you can just very fast skim through it. And basically it teaches you about how to write your first program. It teaches you the meaning of certain program functionalities. Then, it teaches you about basic how the load works, how the store works, and what is the structure for it. So those things, you can take a look at it, and then you can start writing programs in your own way. So please read up on that, and you will be able to write programs. We are not going to have a lab this Thursday. For the very simple reason that your TAs are also new, and they are, this time is a very weird time, because first year batch who has just come in, they have no way that they can contact previous year's people. So, it would require some time for them to absorb this. They are going through this, they are working on it. And from next Thursday, you guys will start having your labs. So once again, there is no lab this Thursday. The lab would start from next Thursday. That is part 1. Part 2 is regarding your exam. We have said that there is going to be one exam. I might take 2 exams. I'm not promising anything, but I might. But at least, if nothing else, I will give you a practice exam, so that when the question comes into midterm exam, you are not totally dumbfounded that how the hell I'm supposed to solve it. So I will also give you some practice problems and then, one probably a practice exam. So that is all about the midterm. So once again, to rephrase it, there is a possibility that we may take 2 midterms, and that is good for students, because if there is only one midterm and if you bomb it, then you lose a lot of marks. Whereas if there are 2 midterms, then if you bomb one, then in second one you can be better. But then it all depends on how much time we have. And for a large class, it is little difficult to take unproctored exam. So I'm not very sure, because our last year's experience of taking online exam was not very good. But take my advice. In my course, when I taught this course last year, people cheated a lot. And some people cheated without using your brain. They were using WhatsApp and passing on answers. And some people would dumbly write down the answers, including spelling mistakes. Right? They were not even taking that much trouble. They would put their phone under the screen. I mean, of course, we knew that, they are doing something like this. So they would put their phone under the screen so that it would not be seen by the camera and do the, jugglery. So what happened was that, in any time, we find this thing that, these people have copied, because, if there is a continuous wrong answer in one question, TS can immediately find out. So it was decided that give seed to everyone, whoever has written those answers. So some people actually might have worked, and some people may have just copied. They all got the same low grade, right? Because people who genuinely worked but they did illegal thing of passing their knowledge, to help their quote unquote their friends, and they all fell down. So last year, the grades were poor. Very few people got an A or AB or, up to BB. There are a lot of grades from CC downwards. And that, I mean, if you're below C, if you are happy, then, I don't care what you do. But this is my advice to you. The world is very competitive. You'll see that, people, there is a cutoff when you go for your interview, right? For job placement. Now, if you are trying to be so kind and help each other, then, you will all be, let's say, in best case, even the dumb student also gets a good grade. Then, it is your loss, because now the person who is coming from outside doesn't know that which one of you is the smarter of the two. Whether the person, they don't know whether you actually wrote the answer and the other person just copied it. So be selfish. Whatever answers you write them down, and do not try to help others. Number 2, don't try to be cooperative. That, I will do question 1 to 10, you do question 10 to 20, and, you do question 20 to 30, and then, we will all send answers to each other. That also doesn't work, because, if we see a pattern in wrong answers, everybody gets low marks, regardless of who has done what. So please do not copy. And finally, if you copy and somehow, if you succeed, I mean, that's very few people who copy get really good grades, right? Most of the time, people who copy just get passing grades. If you want to be satisfied with that, then, there's no problem. You can go ahead and copy, and I don't care, because, what do I have to lose? Right? Because I don't have to give any money out of my pocket. I mean, if you cheat, and if you are happy with CD or, DD grade, then great, go ahead and take it. Because, I don't want to fail those students. I mean, I would be very happy to give them DD or DE grade and, and go out and, deal with it. So do not do copying or anything, because, in the end, it is not going to help you. If you just want to pass, then, you can use any illegal means. And if you're not caught, then, you are lucky. You will get CD grade or DD grade or DE grade, and you will pass. Okay, so that's about the exam procedure and my advice to you on cheating or not cheating. One more thing, which I would like to tell you at this point. I see that the attendance in this particular course, online attendance, is sort of reducing. At the most, there are like 250 or 280 people, which is good in the beginning. And then, it starts dropping. And, after first midterm, somehow they feel that after first midterm, they have learned the whole course. So it is okay if they don't attend. Some people might be thinking that, okay, they post the recorded lecture. So let me just, at my convenient time, or at that, I will save all their lectures and, maybe in the last week, I will just read up on that lecture and then, I will get marks. And it's like, quote unquote, last minute studying or last day studying or last week studying. It doesn't work that way. See, people who mug up things, you can get marks in your school if you mug up at the last day, if you have very good memory, if you mug up everything. Here, there is very few things to mug up. Here in this, especially in this particular course, the problems may be asked, if you can't think, then you will feel that, oh my God, this problem has come from Mars, or where did this problem come from? I have no idea how to solve it. And you have no idea how to solve it because you have not thought through the problem or thought through while you are reading. Reading is not mugging up. You read something, you pause, you start thinking of the implications of what was said. How can I use it? And how can I connect two separate facts which were taught and put them together and use them in a combined way to solve a problem. So that is your responsibility, and you have to learn. So my advice to you is always be regular in the class. I know the temptation is great, but what's the point? I'm not asking any questions. I can listen to the recording because getting up at 8:30 in the morning is too much of a problem. I may as well wake up at like my usual time of 10 o'clock and then listen to it whenever I'm free. But here the question is of attitude. I've been a professor and teaching for last 25 years. I've been teaching both in India and in the US, and I have also taught to the people of industry. And I found out one thing, that people in the end who succeed in life, not just exam, but in life, are the people who are hardworking and people who are conscientious. Hardworking people and conscientious people will not attend or will not miss attending any lecture. Why? Because it is part of the regimen. If it is something has to be done, it has to be done. No questions asked. It is not like, it's not convenient to me, or I don't want to get up so early, or, anyway, I am getting a recorded lecture. So what's the point of getting up at that time? So it is not the question of, whether it is okay to listen to a recorded lecture later or attend the time. If a lecture time is given, you come and attend it. Why? You're forming a habit of discipline, that if something has to be done, it has to be done, right? So please look at it, and the recorded lecture which is given, use it as a revision. If that is like, something you feel that you may have missed, then, you can again listen to it and then find out what you have missed. One more thing, that, whatever is shown in the PowerPoint is for my convenience. I have to give a lecture, so I have written down a point, which would help me structure my lecture. You are responsible for everything that I say in the lecture. So for example, if something is not written on this PowerPoint slide, doesn't mean that it is not in the course. I've said a lot of things about risk versus CISC, which is not everything is there written in the PowerPoint slide. But then, I expect you to listen to me, take notes. It is always important to take notes. See, even at this age, I go to any meeting, I take notes. It does two things. It helps my mind from wandering around. Right? Usually our mind starts wandering after 15 minutes and you start thinking of other things. If you are taking notes, at least you are concentrating, that you are concentrating on the act of writing. So form two habits. First of all, always attend the lecture. without thinking of excuses that, I can listen to this later or whatever, because, you are forming a habit of discipline. And number two, always take notes while you're listening to someone or some lecture, because it would help you concentrate. If you listen to this lecture and, spend maybe half an hour or 40 minutes at the end of the day, because if you think that, I will read at the end of the, when the exam is due, say after a month or so, then you may have forgotten. But if you just today only after this lecture, again, you go through the lecture part and you go through your notes, it will be in your head. And that is called smart working. It puts less pressure on you and will give you higher grades. Okay, so that was some general things I wanted to say. Does anyone have any questions regarding exam or lab or anything? Okay, I believe there are no questions. Okay, so now the first word has come in here and it talks about stored program concept. So the question is, where does this word come from? For most of us, and definitely for you, you'll start wondering that is there any other way of executing a program? So stored program, it simply means that whatever you want to execute, you write the whole program, save it into the memory, and then your processor would start taking one instruction after the other from the memory and will execute it. So that is known as stored program concept. So just like you write your program in C, you pass it through your compiler would break it down into instructions, and then it will be fed to your processor, and processor will take first instruction, second instruction, third instruction, it will start solving it. And then you may start, then what is the other way? I mean, is there any other way? Yes, there was other way, or there used to be other way. And that's what the Turing and other guys did in the Bletchley Park computer that you have seen, where you have to physically connect, make the connections or connect the relays to make it. So I mean, it was not a stored program. So if now someone says this is a stored program concept, so now I mean, there is no other way as of now. Okay, historically it's an interesting thing, but other than that, stored program means whatever you're doing right now is known as stored program methodology. Now in the ARM architecture version 4T, I keep on telling you, I will explain what T is maybe in a couple of slides later. I will tell you what T stands for. T stands for thumb instruction set. So there are in ARM version 4 at certain points. I mean, this is very important. Please remember this. As I told you earlier, that all ARM processors are 32-bit wide, right? So that means they have got 32-bit registers, and then 32-bit registers can be used. So there is a 32-bit data path from first source operand, second source operand, again in 32-bit. Answer out is again 32-bit. So instructions are also 32-bit. So it makes sense. Now then they came and they said that okay, we want to have a instruction which is 16-bit long. Now what they are doing is that okay, add R1, R2, R3, which is a 32-bit instruction format in ARM instruction set architecture. They say we will try to reduce it using 16-bit instruction set. And there is a particular methodology, and so I mean there are actually two separate instruction set, ARM instruction set and thumb instruction set. Now you guys will start scratching your head and say, what's the point of writing 16-bit instruction set? I mean, you've got 32-bit instruction set ARM, and it matches perfectly with a 32-bit processor. So why have a 16-bit instruction set? And it's a good question. But once again, the Answer lies in economics. See, 32-bit memory is more expensive than 16-bit memory, right? So if your data is 32-bit, and if you want to store it in a 16-bit, so if you want to do it, then someone wants to annotate. Why we want to annotate? Does someone wants to explain something? Or you are just playing with the buttons? Ah. Okay. So 16-bit instructions, 16-bit memory was cheaper. So if you want to use it on a very, very cheap electronic device, you would rather buy a 16-bit memory. And it makes sense to put 32-bit instruction somehow, contract it and put it in 16-bit memory. Now there are ways and means to reduce the size of instructions from 32-bit to 16-bit, but not all instructions, some instructions. But data cannot be squeezed into 16-bit from 32-bit. Otherwise, you would lose some data. So, but then, for instruction, it's a good idea. So to help those people or those industries which demanded that they want to make cheap electronic devices and they want to be able to write instructions which is 16-bit so that, you can store them into 16-bit memory, then, it's say, okay, we will develop this for you. So that's why the thumb instruction set came. Okay, so now there are four types of instructions you will see. First, you will find load and store instruction. And as I told you, RISC processor is known to have load store architecture. So what it means is that your processor can connect to the memory only using two instructions. Load means load something from the memory into register set of that processor, or store. That means take something from the register of the processor and put it into memory. The rest of all the instructions, which include your mathematics instructions, which is known as data operations, which could be logical or algebraic, those type of instructions operates only on registers. Okay, so you have to have load store. Then there are going to be data operation, that is algebraic and mathematical. Then there is change of flow, that means the branch instruction, move instruction, store value into PC instruction, so on and so forth. If you don't understand something, please stop me and ask me. I think it would be better than writing into the chat box, because while speaking, it's difficult for me to check the chat box.
Sir?
Yes.
Can you explain load and store again?
Okay.
Thank you.
So load and store are two instructions. They are very well explained in your book. Which chapter? I think it's in chapter number 5. And I recommend that you read up to chapter 5 instead of 4. Okay, so this is the one, you might be a similar thing. I hope you can see this. So chapter number 5 and load store instruction. There are various ways of loading and storing, and this chapter, it's a very easy chapter to read. You can just flip pages and it's all very intuitive. So load and store are two instructions which are allowed to access the memory. So in simple language, this is your processor P. It has got register set, so starting from R0 to R15. It has got ALU to do all your programs, some other required material to do this. Now, it has to connect to the outside memory, right? Because, it has to, whatever the answer is generated over here, there are only so few places. So, this thing has to be put into something else, saved it, because otherwise it will be overwritten. So you have some memory which is outside, probably let me call it as cache memory. Or in this particular case, if you don't know what cache memory is, just call it memory. Now, you want to bring in some instruction or data from memory into register, or you want to, some value is generated, say add R1, R2, R3. Now, someone has to put the values into register R1 and register R2. So before you can use instruction like add R1, R2, R3, that means add the content of register R1 with content of register R2 and put it into register R3. But what is there in register R1? Things are not going to come by magic. So you have to put in instructions like load some value into R1, and this is what instruction is, or what pseudo instruction you have to use will be given. So load R1 with 10. I'm not writing into exact syntax of this ARM architecture, but I'm just writing a pseudo code. Then you will say load something into R2, say 15, and I'm writing in decimal instead of binary because it's easier to read. So then, only then you can use this instruction. So first is load. You load something from memory location. So here, either, you write down direct value or you write down memory location. So normally it is written like this. M is not actually written, it is the address is written like this. So address, memory location address 100011 something. So that means go to this memory location, which is given by 100 blah blah whatever it is. So go here, read that value and store it into register R1. Then here also you may give some address, different address 1100 whatever, lot of ones and zeros. So what it means is go to this particular memory address, read the content and write it into register R2. So now you have got values in R1 and R2. And then you put the answer into R3. Now suppose if this instruction is in a loop, then unless you save R3, it will be overwritten by something else. So in the after add, you will have to write a store instruction. And store some value of R3 into some memory location, right? And then, again, go into loop. If this is going to be, and, probably you increment it, and then new value would be here in an array. And from that, you load it into R1 and R2. So, basically, you are taking two arrays and taking one value from the one array, second value from another array. You're adding them together and putting that into the third array. So this is what the fundamentally something like this would be done. And after doing this in store, then you will have some kind of another that increment this by one, increment this by one, so that you go to the next element of the array and so on and so forth. So in load store architecture, you are accessing the memory either for reading or writing using only two instructions, load and store. You can't say add R1 or add memory location something with memory location something and put the value into memory location something. No, you can't. That is not allowed. Adding is done only between registers, and storing is also for add instruction. That answer has to be stored into a register only. Only store instruction is the one which is legally allowed to take a value from the register and store it in the memory. Is it clear to everyone?
Sir, you said that your
Yes.
load instruction will load from cache memory. So,
Yes.
sorry, can it load from the random access memory or other hierarchy of memory?
Sure. It's like this. Let me give you an example. Say there is a small kid in the house, right? Whenever that kid is hungry, he or she would go to the fridge, open the fridge, and get things from there to eat, right? So for a kid, the fridge is the thing that, whatever the food is there, it's in the fridge. But the kid doesn't know that there is a whole supply chain behind it. So probably his or the kid's parents, they would have to go to the supermarket or vegetable store and buy something and stock it in the fridge. Then parents don't know where the supply chain is coming to the supermarket or vegetable vendor. Then, for them, there is another supplier, a major supplier who supplies to the supermarket, or a farmer who supplies to the vegetable vendor. So there is a whole chain behind it. But to a kid, everything comes to the fridge, because kids doesn't know beyond the fridge that there is a world beyond the fridge. So very similarly, for processor, whatever it wants, it makes a demand from the cache memory, the first level of cache memory. That, data I want, if it is not there, then there is something which is known as memory controller. It has to do all the juggling around that, it is not found in the cache. I will have to look at the next lower memory, or if it is not there, then I have to go to the next lower memory and get things back. I'm not saying too much on memory, because memory itself is one of the biggest topics of this course, and it is going to come after a few weeks. But this is what I'm telling you, that at the moment, for the processor, first level of cache is the memory it sees. It doesn't know what is beyond it. So whatever it wants, it makes demand on that cache memory. And cache memory is two types. One, you store instructions. Second, you store data. So whatever you want, or whatever processor wants, it should get it from there. If it is not there, then someone else, that means direct memory controller or memory controller, whatever hardware is there, has to look into it and supply the data. Okay.
Yes, sir. Yes. Thank you, sir.
Okay. So this is your load store architecture. Now, I will not explain each and every instruction in detail, because it is very well explained in the book, and there is no point of wasting too much time of, say, add R1, R2, R3. I mean, what is there to teach? I mean, it's intuitive, right? You take values of register R1 and value of register R2 and add them and put it into R3. That's intuitive. Same thing with store. With load, there are going to be several different things. So I will mention load and store in a little bit of detail. I mean, it is intuitive and you can do it, but just for my satisfaction, I'm going to tell you about this and also tell you what's the reason for having those kind of things, which you may feel is like, okay, this is A is very similar to B. I mean, these instructions are very similar. Why have two separate instructions? It is increasing the bloat. Why not have just one instruction? So I will also tell you the reason for having those kind of subgroups of load and store. Okay. Now we are going to talk about pipelining concept. Actually, in second part of this course, we are going to study this in much more detail. But to understand how instruction goes through, even from programmer's perspective, it is good to give some idea. And this idea is important for understanding something we call as program counter. So before we come to the concept of program counter, let's just say that this is the type of processor you will be using for your lab, ARM7TDMI. And it is one of the most basic processor which was developed in 1995. But don't make a mistake. Still, it is sold in the market and people are extensively using it because it is extremely cheap, extremely efficient, and so popular that people are used to it. So it is still used. I mean, in volume wise, it is making a large number of sale. So there, it is solving the problem in 3 steps. And the 3 fundamental steps are fetch, decode, and execute. So how does this fetch, decode, and execute work? So first one is fetch. Then second stage is decode. And third stage is execute. Now fetch, first stage is simple. Now, as I told you, my processor has got 15 registers and ALU and some other hardware which is required to do the needful. So it has got R0 to R15. And then, some maybe one register extra, which I'm going to talk to you about. It is known as program counter. And then there is ALU and so on. Now fetch means you need to get the instruction. So there is outside memory, and the memory is divided into 2 parts. First one is instruction memory and second one is data memory. Right? Instruction memory and data memory. So this is your instruction memory where your program is stored. You have written, say, in your first assignment, you will write a 5-line program or 7-line program. So that program will be stored in the instruction memory. We assume that how it has come to the lowest level or cache level thing, it has just come. We don't see that. Right now, we don't want to explain the function of memory controller or anything. Right now, assume that there is only cache memory. So whatever program is there, it is written in this stage only. There's no more memory space other than this. Fine. So the fetch means you fetch something from the memory. And if the memory address is this, you go and fetch this instruction and put it into one of the registers. Now the value has come over here. Now in fetch stage, you use a program counter. Are you aware of the function of program counter? From your DLD class?
No,
Okay.
sir.
We studied about counter, but not program counter.
Okay. I mean, it's very simple. It's a counter. But it's called program counter because suppose my memory is, say, 100K. Right? So I mean, it's a big memory. Now I need to start my, and I mean, a lot of there's a boot sector over here, and there is some read-only memory, and this is the part which is given to the user to write his or her program, and so now when you say, okay, start executing the program, then the processor would naturally ask that okay, where's the first instruction of the program? Right? Where should I fetch it from? There are this many memory. And think of memory as pigeonholes. That each pigeonhole is a 32-bit wide register, and they have stacked them. And there are like 100K of them. You want to read from some memory location. Now, who would tell processor an address that which is that first instruction? Where does it lie? So there is operating system which is outside the scope of this course, but assume that somehow it puts the starting address of your program into this program counter. It says that at this particular location your program start. So it will put this instruction over here. And this instruction is here, then it would tell the fetch cycle that go and fetch something which is given here. So the fetch cycle will bring something. Then it will go into decode stage. Now in the decode stage, it is getting something like number like 10011 and blah blah 32-bit number it is getting. Now fetch stage doesn't know what this ones and zero means. It just says, okay, my job is just to go to the memory location which is given by my program counter, get that particular whatever ones and zeros are there, bring it and pass it on to the next stage, which is decode. Now decode is the one which would try to make sense of this instruction. So first it has got the hardware inside, and the hardware knows that the structure of this instruction is, and this structure is given in your book. You don't have to remember how it does it unless you actually go for implementing it or designing a processor. If you're a programmer, then you say, okay, I have just general idea how it will be decoding it, but you don't have to actually remember how it is doing it. But there is a hardware which is given over here, that first 5 bits, that means the MSBs, that is most significant bits, this would be opcode. The word opcode stands for operation code. So opcode means whether it is add, whether it is subtract, whether it is or XOR or whatever. Each one would have a separate opcode. So it would first decide, oh, this operation is add. So to execute stage, it will send a signal. Okay, the next instruction which I'm going to send to you, you will have to add something. So tell your ALU that next operation will be an add operation. Fine. Then it would read 2 source operands, and the source, it will come from R1, it will decode it, and then come from R2. So it will tell instruct register file that 2 data will have to come from R1 and R2. I think this I have drawn slightly wrong. Instruction does not go into register file. Instruction floats through a pipeline which is given over here. So this stage, fetch stage, will do nothing but fetch it and pass it on to the next one. No processing will be done. R1 and R2 would receive data from data memory. So from here it will go to register. Now this first instruction will go to the decode. In decode, it will figure out, okay, this is add value of R1 and R2. It would say, okay, you will have to read these 2 values and send it to execute. So execute will accept the value of R1 as a 1 input, value of register R2 as second input, and will store the value in third register R3. Right? So this is how fetch, decode, and execute would work. And then then second round will come and third round will come. So you can, just like we gave the previous example, that before we write add instruction, we have to write load instructions, which would load data into registers. So we would write load R1 from particular memory location from data register, load R2 from particular location in data register. And then you write add instruction which says load R1, and value of R1 is already there because we wrote load instruction which was previously fetched and decoded and executed, so on and so forth. And after this add, I will have to write add instruction. I will have to write a store instruction because R3 which is there, it has to be stored back into data register or some memory. Otherwise, if this is going in a loop, then the second loop will come and it will override this R3, so you will lose that data. Because does anyone have any question in this fetch, decode, and execute thing?
So what is it, sir?
Okay, I mean, someone else was trying to speak first.
Sir,
Yes,
what is the default? So what is default program in program counter means?
What is
When computer starts, what is the value pointed by program counter?
okay? So that I can't tell you what the value would be because it will be determined by the company, but it will go to the boot sector. The boot sector is like initial startup program, which would do the housekeeping kind of thing that clean all the counters, clean all the registers, load the important part of the operating system. So that is what we start. So when you freshly start a processor, any processor, embedded or laptop class processor or a server class processor, initially it will go to the boot sector. Does it answer your question?
Okay, sir.
So boot sector is nothing but a program. Again, everything is a program. So boot sector is a program which knows how to initialize the whole or create the system setup. So that's what you have BIOS in your laptop. If you mess up your BIOS, then your computer won't start.
So that is all boot sector means.
Yes, yes. Anyone else?
sir, how does the decoder separate the opcode R1, R2 such instructions?
Okay, so it would have, that is actually comes to the implementation part. That implementation part, actually, I wanted you to design a processor this time, but since I don't think we'll be able to do it now, but all you have to do is design circuitry using gates, which would be reading this 26 bit number 26 to bit number 31, right? Those are the MSBs. So it knows there is a circuitry which is assigned over here, which would read this value and decode that it is 10011, and then it would send the signal to the execute stage, the ALU which is in the execute stage. Okay, you have to do this work. The next work you have to do is addition. And then decode stage will also read this part. It will figure out that it's an arithmetic type of instruction. So here would be the source 1, this would be source 2, and then the third would be destination. So from the, then that is actually the art of the designer or person who designs the processor, that it has to give enough decoding power or decoding circuitry, which circuitry you don't have to design using starting from the transistor. You just use gates. And so particular gates would say, okay, I'm reading this, and if I see first 2 as 1 1, then those are all arithmetic instructions, so that the format of that instruction, if this is an add instruction, then the format would be source 1, source 2, and destination. If it is add immediate, then there would be register and immediate value, right? So it knows when it decodes this, it knows that how the rest of the thing would be decoded, and then how that would be decoded, it is programmer, as a designers or implementation engineer's responsibility. It is given in the textbook hardware software design. So if you're interested, you can do it in a class project. If you want to show it in your resume, you can design a 3-stage processor. They are given actually everything which is required here. MTech class students regularly do it, with a course for that, and this is very similar. But MTech students have been given additional responsibility of design this using Verilog language. So I think Verilog language, it will be difficult to teach for a very simple reason that the tool costs a few GBs, and some of them are proprietary. So that we have them here in DICT, but since all of you are sitting outside, you cannot access it properly. So right now I've dropped the idea of teaching you how to design a small processor, but this is how it should be done. So it is fetch, decode, and execute.
Can you please explain
Hello, sir.
Yes.
Yeah, so I was so as you had explained that fetch wouldn't store the data in registers, right? So
Yes,
yeah.
correct.
So which process would be storing the data? As you had here shown two memory segments, one of
Okay,
which would be taking the fetch, and the other one would be storing the data in register.
right, correct. So fetch stage would be fetching only instruction, as you can see here. That fetch stage would be fetching only instruction from instruction memory. Then you will say that, okay, where would data be, or in which cycle data would be accessed? So as you will see, there is register read, right? So it is more clear in 5-stage pipeline, which is known as memory access. So this memory access is actually data memory access. So if you throw in your load instruction, it would say load something into register R1 from some memory location. That instruction will be fetched. It would be decoded over here. It would read the register, and registers would say that, okay, it is R1. That's where you want to put in. Nothing would happen in the execute stage unless it is address calculation. I will come to that later, that what address calculation is all about. But let's say it's a very simple. You have given direct address to the load, that you load something into register R1 from a memory location X. So nothing will happen over here. So instruction will come in and go out. When it reaches this stage will access data memory. So in fact, this is what I wanted to teach you, that only load and store would be using this stage. No other instruction would be able to use this stage. So if it is an add instruction will be fetched, then it will be decoded, then it will be added, and value of register R3 will be created. You have not now written the value into register R3 yet. It is just lying there in the output of ALU. And then memory access stage, nothing would happen. No work will be done. And in register write stage, it will write into register R3. Now, this is again an important concept for you, that for all instruction, they don't do work in all stages. There are some instructions which don't do any work in a given stage. So for example, all instruction except load and store will just get in and get out. No processing will be done on it, because this stage is not doing any work for them. I mean, it is not required for them, other than for load instruction and store instruction, right? So to give you an answer to your question, that load and store will work only when it comes to this stage, which is memory access, and this is where your data will be stored. And this thing has implications, which we'll see in implementation. This may call data hazard, because something is following the other, and the value of R1 is created over here, and here in decode stage, value of R1 is wanted. So how are you going to get it? Anyway, don't worry
Yes,
about
sir.
that too
Sir,
much.
that was only my doubt, because if we are performing some operation which is stored in the register, and that needs to be fetched before and
Right. So I think
operation.
you have pointed to a very important concept. See, in a pipeline processor, instructions are sent one after the other. So when instruction number one, say instruction number 1 is here, then 2, 3, 4 are waiting. In second cycle, instruction number 1 will move over here, and instruction number 2 will come here, and then 3 and 4 would be waiting. In the third cycle, instruction number 1 will move over here, 2 will come over here, and 3 will come over here, and 4, 5, 6, 7 would be waiting. So this is how it would progress. So suppose you have, I'm just answering this question because someone has asked it, and this question is called data hazard. So someone has written a program that load register R1 from certain memory location. And the following instruction is add R1, R2, R3. Then, his question is that, when the second instruction, which is add instruction, comes here, it wants 2 registers. So let's talk about 5-stage pipeline. It's easier. In second stage, your instruction wants to read the value of register R1 and R2. But the value of R1 has not yet been calculated. Why? Because load instruction is here at that time. When your add instruction is here, your load instruction is here. So that means it has not been able to yet contact the memory, data memory, to put in the value. So then the value, if it reads the value of R1 at this stage, it will be a wrong value of R1 and your program will be destroyed. Why? Because you are reading the wrong value, the old value of R1, which was done before this. So then, you will have to put a 1-cycle bubble, means no operation. So you will send a second instruction, which is known as NOP, means no operation. So it will do nothing, 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 nothing. So the whole purpose of that instruction is to increase a gap of 1 cycle between these two. Okay. You have just forced me to jump ahead and talk about data hazard. But, this is what it is. So I answered it because someone asked a question. If you don't understand it at this moment, don't worry too much about it. Right now, what is important to you is what is a pipeline concept and how instructions will move on. Are we done? How are we with time? Have we exceeded the time?
Yes, sir.
Okay, I'm sorry. I will stop here. And we stop at this point. And we don't